A very good afternoon to all the participants who have joined in for today's session. I would request the faculties to inform the peers so that we would be starting the session at 3 o'clock sharp.
इसकी मनीषा जो सॉरी
Gentle reminder to all the faculties and dignitaries to inform the faculties to join in, other faculties to join in the session as we would be starting shortly. A warm welcome to all the dignitaries from colleges, faculties, HODs, principal who have joined in for today's faculty development program on quantum computing starting today. So before we could start, let me give you a quick intro about XLR. XLR, founded in 2013, having 8 branches in 5 cities, founded by IIM ISB alumni Mr. Ram Tawa, headquartered in USA, Houston. So far, we have trained 8 lakh plus students and professionals on the emerging technology trends. We cater to the skilling needs of individuals, institutions, and industries. And our strength is our premium associations, iHub, Divya Sampark, APSSDC, APSHE, TASK, KMDC, IIT Madras Pravartak, IIT Roorkee, BITS Pilani, Hyderabad, NASCOM Future Skill Prime, and Swayam Plus, where our 18 plus courses are being approved under NASSCOM, and we have it on the NASSCOM Future Skill Prime platform. And as well, we have 15 plus courses of ours on the Swayam Plus portal. We have been constantly recognized for our exemplary work by Deloitte twice, Silicon India, Analytics India, PMP training, and many others. To give a short glimpse on our decade of training excellence so far, 80,000 plus faculties are trained under this platform, both STEM and non-STEM domain. Students close to 8 lakh plus. Webinar, seminars close to 600 plus on the technical training program, that is 40 plus technical courses. And we have 2,000 plus academy partners and 5,000 plus placement partners. So far, we have a mix of engineering degree and others whom we have trained both in the faculties and in students. For today's program, we have close to 2,265 registrations, which is again a mix from engineering, BSc, BCA, Masters in Computer Application, and many other categories. So, what is a everyday learning program? Through our everyday learning platform, we provide application oriented, industry oriented learning on various technology trends, which supports the learner on getting the complete hands on training on the trending technologies and also helps the colleges in fulfilling the NAC and NBA requirements. Through our EDL, we also offer industry MOU, industry webinar, industry FDPs. All of these are conducted through our learning management system platform. And we do a lot of professional training. And the learner who enrolls for any of our courses online will have assignments and assessments to showcase their learning. And also, we do have the industry use cases on our LMS platform. There are a lot of placement preparation learnings which will happen during this journey of the learner. So this is how our LMS would look like, where a learner who enrolls for any of the programs will get the login credentials. Once he logs in, he would be able to see the upcoming events and the events which have happened in the past. So the recordings of the past events are also available where the learner can go through. And these are some of our student development programs so far we have conducted, where constantly participating colleges with close to 1,600 plus. And these were on the most popular programs like DSA for campus placements, ChatGPT, Advanced Excel, artificial intelligence, mobile app development. We do have the list along, but these are most popular programs. Similarly, on the faculty development program, we have conducted 45 plus FDPs. Constantly participating colleges are 1,519. And the most popular programs under FDPs are cybersecurity, ChatGPT, data analytics, digital marketing, deep learning, artificial intelligence, and many more. A learner who enrolls for the student development program or a faculty development program will receive the participation certificate. And these are some of our certificates which we have issued to the learner during their SDP and FDP events. These are some of our recent engagements which was at IIT Roorkee on data analytics using Minitab tool training for research scholars and faculties. And this is for the students on Power BI training at BITS Pilani Hyderabad campus. And this is one of our initiative on to support the learners, that is especially the final year engineering students who crack the job interview, where we curated a 5 subject module to 40 plus hours on coding skills, quantitative aptitude, logical reasoning, verbal ability, soft skills, and tips and techniques to raise their group discussion and personal interview. And this was in support with iHub Divya Sampar with joint collaboration in where 5,200 plus students received the prestigious certificate. So for this event, we had 50,000 plus registration, wherein we had the maximum registration through APSSDC, and it is 10,150 engineering students attended this program. These are some of our EDL programs which we had conducted in the past. the month of September, October, and November. So, without much further ado, let me take you through the faculty development program on quantum computing, where I take the privilege and honor on behalf of XLR to introduce the dignitaries who are present today for this afternoon. Dr. Kamaljit Brewal, Principal from Khalsa College for Women. She has 34 plus years of exemplary leadership in advancing education, student welfare, and institutional development, and distinguished academic researcher with numerous publications in reputed international journals, awarded the Award of Honor for the Best Teacher, and recognized for her visionary efforts in sustainability, entrepreneurship, and innovative educational initiatives. She is a visionary mentor dedicated to student empowerment, community development, and building strong academy industry collaboration. A warm welcome to you, ma'am.
Thank you so much. Am I audible?
Yes, ma'am, you are audible.
Uh, can I continue?
Yes, ma'am, please.
Respected guests, esteemed resource persons, dear colleagues, and beloved participants, it is a proud moment for me to welcome you all to the inaugural of 1 week faculty development program on quantum computing hosted by Department of Computer Science, Khalsa College for Women, Civil Lines, Ludhiana, in collaboration with our esteemed training partner, XLR EdTech Private Limited. We are deeply grateful for this academic alliance, which promises to open fresh avenues of learning and innovation for both faculty and students. Khalsa College for Women, Civil Lines, Ludhiana, founded in 1958, has always upheld the noble mission of empowering women through education with over 6 decades of distinguished service. Our institution continues to stand as a beacon of knowledge, opportunity, and progressive learning for young women, shaping them into global citizens and leaders of tomorrow. The college provides a strong multidisciplinary learning ecosystem with high quality programs across sciences, commerce, humanities, business management, computer science, and various vocational courses. Our experienced faculty, modern labs, and technology enabled classrooms ensure meaningful and holistic student development. Our journey of excellence is reflected in meaningful achievements year after year. Our students consistently shine with remarkable university results and high academic progression. We offer technologically advanced learning environment with state-of-the-art laboratories and teaching tools. A strong research culture inspires our faculty and students to think critically and innovate constantly. Our learners excel with this equal zeal in sports, NCC, NSS, and performing arts, earning laurels at various levels, both national and international. We ensure holistic development through mentoring, counseling, scholarships, and career guidance. With dynamic industry associations and hands on training, we enable experiential, technology driven skill development that enhances employability and future readiness. Our alumni today shining in diverse fields, be it academics, civil services, entrepreneurship, corporate, or creative sectors, are a true reflection of KCW's legacy. The Department of Computer Science has always been ahead of the curve, introducing students and faculty to emerging technologies like AI, data science, cybersecurity, cloud computing, and now fascinating realm of quantum computing. Quantum computing marks a transformative leap, redefining the way the world will compute, communicate, and create. Its application spans national security, drug discovery, advanced simulations, financial modeling, and much more. It is both a challenge and an opportunity for the academia to keep pace with the rapid evolution, and this FDP is a step towards that direction. We are delighted to have the participants from different institutions with us today. I extend my sincere appreciation to the organizing team for curating a promising week of learning and distinguished experts from the field. I am confident that the sessions will inspire fresh thinking, inspire research pursuits, and build strong capacities for future advancement. With these words, I once again welcome you all and wish this program a resounding success. Thank you and God bless you all.
Thank you very much, ma'am, for highlighting such important academy perspectives. And your talk was both inspiring and intellectually stimulating. Thank you
Thank
very
you so
much.
much.
So let me call upon our next dignitary for today's afternoon, Dr. V. Salim Basha, Principal from SKR and SKR Women's Degree College, Kadapa, Andhra Pradesh, in academic and research excellence, chemistry educator and researcher, completed a UGC-funded minor research project, published 21 research papers, authored textbooks, and serves as a PhD guide and reviewer for reputed international journals. He is also actively organized and participated in national and international seminars, adopted innovative teaching practices, and holds membership in the Indian Chemical Society. He brings in some strong administrative experience and has received prestigious honors, including the Best Environmentalist Award and the Best Resource Person Award. A warm welcome to you, sir.
Good afternoon, madam.
Very good afternoon, sir.
Am I audible, madam?
Yes, sir, you are audible,
Yes.
sir.
Thank you. Thank you very much, ma'am. Good afternoon to all the respected faculty members, the resource persons from XLR, and our enthusiastic participants. Really, it is a very wonderful opportunity for us. I thank Director of College Education, Dr. Narayan Bharat Gupta, sir, Joint Director of College Education, Dr. C.H. Krishna, sir, for encouraging us to conduct this type of FDPs. I thank XLR for their collaboration in conducting this type of wonderful FDPs. Yeah, it gives me great pleasure to inaugurate this faculty development program on quantum computing. At first, the word quantum may sound complex or distant from the everyday teaching, but in reality, quantum simply refers to the smallest building blocks of nature, the tiny particles that makes up everything around us. And quantum computing is a technology that uses the strange but powerful behavior of the particles to solve problems much faster than today's computers. So quantum computing is not just a computer science topic. It is a mindset shift. It teaches us new ways of thinking, problem solving, and understanding the world. Just as the internet changed the way every field works, from commerce to biology to education, quantum technologies will influence all disciplines directly or indirectly. Quantum computing is the prestigiously launched by the government of Andhra Pradesh as Quantum Valley at Amaravati. This is the treasure of present generation. This will be the treasure of future generations also. In this coming years, quantum concepts will play a role in drug discovery, finance and optimization, climate modeling, cyber security, data science, and advanced materials. Our students will step into a world where quantum aware skills will give them a strong advantage. New career path will emerge. Quantum programmers, researchers, analysts, and engineers. And even non-technical roles will require a basic understanding of these technologies. Yeah, this FDP is a wonderful step taken by our IQSC team in collaboration with XLR towards building a forward-looking academic environment in our institution. I congratulate the organizers, especially Dr. C.V. Krishnaveni, IQSC coordinator of this institute, and welcome all the participants to make the most of this learning experience. Let us embrace this journey together and prepare our college, our participants, our faculty, and our students for the next big wave of technology. Thank you very much. I wish the program a great success.
Thank you very much, sir. We are grateful for your illuminating address, and your depth of knowledge has greatly added to the intellectual value. Thank you very much again.
Thank you very much, ma'am.
So let me move on to the next dignitary for today's afternoon, Dr. Ravi Gujula, Chief Industry Connect and Skill Development, ICFAI Hyderabad, a distinguished PhD graduate from IIT Hyderabad in computational fluid dynamics, and he blends over 15 plus years of corporate experience with a decade of academic and administrative excellence. He is a former chairman of Board of Studies at KL University and a principal in AP. He excels in skill development, establishing centers of excellence, and strengthening industry academia collaborations to make graduates industry ready. A warm welcome to you, sir.
Thank you, Nitya, for giving an introduction about me. Uh, Respected colleague, distinguished speakers, and registered participants, good afternoon to one and all. It is a truly pleasure to join with you today for this faculty development program on quantum computing organizing by XLR in everyday learning. And as you know, the XLR is a leading from front in organizing a many skill development program on various cities within collaboration with the different institutions. So I'm representing from ICFI Group. We have 11 universities across Pan India. And so I congratulate the organizing team for creating this excellence platform to achieve our academic community with future ready competencies. So the kind of faculty development program, how XLR is taking forward and how it is going to be benefit in particularly higher education institutions, the transformative role of faculty development programs. So it serves as a backbone of academic excellence in updating knowledge and relevant to the industry and what industry is expecting. As a faculty of higher education institutions, you need to adopt these technologies. In today's world where knowledge evolves faster than curriculum cycles, faculty development empowers to faculty stay aligned with the global technology shifts, integrate the contemporary industry insights into classroom teaching, to develop interdisciplinary and research-oriented learning outcomes, build confidence to mentor students for emerging careers by adopting emerging technologies. A strong faculty body directly translates to strong student outcomes. Therefore, the faculty development become crucial investment in long-term academic strength of our universities. The impact of emerging technologies on higher education. Today, we are witnessing the profound shift driven by emerging technologies like artificial intelligence, quantum computing, data science, blockchain, Internet of Things, cyber physical systems, and many more technologies, such as disruptive technologies. These technologies are reshaping what we teach, how we teach, whom we are preparing our students to become industry relevant. So, in higher education, particularly these kind of faculty development programs are enabling new learning architectures for smart classrooms to AI-based evaluation, adaptive learning platforms. Technology is making education personalized efficiency. The future-aligned curriculum, then enhanced research capabilities, like particularly for the courses on, artificial intelligence, quantum computing, cyber security, cloud computing. DevOps are no longer optional. These are essential for global competitiveness nowadays to compete globally and to build new applications to solve for industrial problems as well as uh, the society problems. So basically, we as a faculty we need to create a job-ready talent ecosystem. So that's where these kind of faculty development programs like today XLR is organizing quantum computing. To focus today, faculty development program is itself a frontier technology with applications in complex problem solving, simulations, which applications particularly in finance, material science, national security, cyber security, um, and coming to the collaborative approach, like academic industry collaborations for future learning. So this is a very important aspect in higher education. So no longer, classroom teaching or just book based delivery of a classroom that is obsolete nowadays. So a hallmark of world class education is strong collaboration between academia and industry is essentially required at this juncture. Today, no university can operate in isolation. Industry partnerships helps for higher education institutions, particularly like keep our curriculum relevant. Industry brings real-time insights and latest technological tools and expectations to the academia. Provide experiential learning by collaborating with the industry, like uh, organizing or offering internships to the students, offering live projects, conducting hackathons to provide solutions to the societal problems, like these faculty development programs, bridges the knowledge and practice gap. And also this industry collaboration create opportunity for innovation and entrepreneurship, where establishing a center of excellence is in support of industries. The train the faculty fast with these latest tools will provide through collaborations. Prepare graduates for global talent landscape, particularly when you are collaborating, working with the companies like IBM, Google, Amazon, Oracle, Zoho, and other companies. The universities ensure students become globally competitive. To create future ready learners and industry ready graduates who contribute meaningful to the, as per our Honorable Prime Minister Vikashit Bharat 2047. So the today faculty development program, the quantum computing represents a revolutionary leap behind the limitations of classical computation. Basically, the quantum computing powered by the principles of quantum mechanics, superposition, and entanglement, quantum interference. The key advantage of quantum computing, the high-speed problem solving for real complex problems, particularly in the cryptography, optimization, and the molecular modeling, drug discovery, and artificial intelligence. And also the breakthrough research in enabling simulation of complex quantum systems for material science, discovery, and climate modeling. And when the quantum computing talking about the computation speed, it's fourfold of existing computational speed, like transforming industries like the banking sector, healthcare, logistics, cybersecurity, and advanced engineering increasingly rely on quantum algorithms in future. So why quantum skills matter today is because the quantum technologies are expected to share a global technological landscape, future workforce. Developing quantum competencies empowers the faculty, researchers, and students to stay at forefront of innovation, contribution to the India's emerging quantum ecosystem across the pan India. So I request all the faculty members who are part of this faculty development program today. Uh, I encourage all the participants engage deeply with the trainer. XLR generally provide a trainer from the industry experienced trainer. So where they discuss about the experiments with the tools and the concepts. All faculty uh, engage and to interact to interact with the trainer and then gets hands-on experience and translate this learning into a classroom innovation. Once you have perfectly understand the concepts of quantum computing, then go back and encourage students and explain them with the real-time applications and inspire students to explore emerging fields, like where the quantum computing applications can build applications to solve societal problems or industry problems, contribute to the research and also in digital transformations. So these concepts and the training is more interactive, so that concepts you can grasp the concepts and try to build an applications by applying the tools. So together, let's ensure that institutions remain at the forefront of academic excellence, technology adoption, and nation development. And I request all the faculty and students and research scholars to engage with this 5 days faculty development program. And I think I request trainer to be the sessions more interactive, so that the faculty will understand the concepts, and then they go back and encourage the students to do uh, better delivery in the classroom. So thank you for giving an opportunity. On behalf of ICFI Group, I thank you. Thanks ICFI Group for providing this opportunity, introducing this quantum computing to across pan-India level to our institutions. I wish you all a highly insightful and enriching learning experience in this quantum computing. Thank you very much.
Thank you very much, Ravi sir. We sincerely appreciate your academic leadership and valuable insights you added today, and that was very much important and as well helping the supporting the learners and the faculties who have joined in today, sir.
Thank you.
So let me call upon our next dignitary for today's afternoon, Dr. Bindu Garg, Professor and HOD, CSE Business Systems and Computer Science Engineering from Bharati Vidyapeeth College of Engineering, Pune. She has 20 plus years of expertise in machine learning, IoT, data mining, time series forecasting algorithms, and AI. She has honored 100 plus peer reviewed research papers, holds 10 patents, and has successfully led government funded projects worth over 70 lakhs in collaboration with DRDO, DSD, and AICTE. A respected academic leader, she serves as a reviewer for reputed IEEE, Springer Journals, and is a distinguished Board of Studies member and a lifetime member of CSI. A warm welcome to you, ma'am.
Yeah, thank you very much for inviting me. Am I audible?
Yes, ma'am, you are.
Thank you very much for inviting me. Respected faculty members, industry expert, all participants, organizers, one to all present here. I would like to welcome you all for the faculty development program about the quantum computing organizing by the Bharatiya Vidyapeeth deemed to be University College of Engineering in association with the XLR Private Limited. It's my pleasure to welcome you all this faculty development program about the quantum computing. First of all, I would like to tell something about the Bharatiya Vidyapeeth. Then I will be speaking little bit about the quantum computing. The faculty development program on the quantum computing organizing by the Bharatiya Vidyapeeth and XLR has consistently, the Bharatiya Vidyapeeth has consistently ranked among the top 100 universities in India with NAC A++ and offer comprehensive UG, PG, and PhD program. The Computer Science and Engineering Department continue to strengthen industry-relevant learning and nurture future-ready professionals. As a constituent unit of Deemed University, we enjoy the autonomy to design innovative, applied, and the forward-looking curricula, a philosophy reflected in our strong faculty development initiative. Over the year, we have successfully conducted FDPs in collaboration with XLR on agentic AI, prompt engineering, and generative AI, along with the skill development programs that emphasize the importance of major and minor research projects. These initiatives have enabled our faculty to stay aligned with the emerging technologies, evolving pedagogy, and the research-oriented learning. Such efforts highlight transformative role FDP play in preparing future-ready educators, especially as disruptive technology like AI, quantum computing, IoT, and the cybersecurity reshape higher education and demand curricula, redesign experiential models, and problem-centered approaches. Academic industry collaboration like XLR, the very good collaboration further strengthen the mission by providing exposure to real-world tools, mentoring ecosystem, research networks, and innovation platform. With this FDP, we once again reaffirm our commitment to preparing faculty and students for the future like the Dr. V. Sleen Baza talk about very true about quantum computing. The quantum computing, like the understanding the quantum computing nowadays in the colleges, institute, and the other industry also is very, very crucial because it promises to solve problem impossible for the classical computers. Revolution field like the machine, drug discovery, finance, cyber security, breaking current encryption, the creative neurons, AI, and material science by simulating complex system and optimizing huge data set, impacting everything from climate modeling to better batteries and GPS. So it's very, very important to understand the concept of the quantum computing and application of the quantum computing is a paradigm shift. We have to understand, we have to move and come with the technology, moving beyond current limits to tackle grand challenges and the creating new industries. Now it's really, really very encouraging also and the inspiring. Like we are very thankful to the industry XLR who's coming forward to talking about the quantum computing, which is the very latest and the challenging field to understand in the field of this disruptive technologies. So I would like to again extend a warm welcome to all participants and very, very thankful to the XLR as we begin this exciting journey in the transformative potential of the quantum computing. Thank you very much.
Thank you very much, ma'am, for your inspiring academic insights. So let me call upon our subject matter expert, Mr. Vipul Saxena, material scientist, having 9+ years in quantum technologies, advanced materials, client consult, plus having additional 8 years of experience in quantum computing and AI. He's a key contributor to graphene-based quantum devices, photonic qubit interfaces, semiconductor materials for next-generation quantum hardware, and he has proven ability in project management, research, and global technical education across industry, academia, and professional platforms. A warm welcome to you, Mr. Vipul Saxena.
Okay. Yeah, thanks for introducing me. So first of all, good morning, good afternoon, everyone. So it's a privilege to join all of you today at the inaugural session of this faculty development program on the quantum computing. And I also want to thank the XLR for this thoughtful initiatives for inviting me as the distinguished speaker. So first of all, this all of us we are going with the moving with the FDPs. So I just want to highlight some importance and roles of the FDPs in our life, actually professional life. The first of thing I want to talk about the transformation role of this FDP. So this faculty development program, that this is for more than training workshops. They are like catalyst of academic evaluation. So they are providing you the acceleration in teaching. And currently in this scenario that we are having a different technologies and a fast changing technologies, the knowledge cycle is no longer measured in decades. So everyone knows because this is the internet booming every time we have to hear. And more ahead from the internet, there are AIs, chat boxes are there, which are having a full of knowledge and the interdisciplinary knowledge. So you are inputting all the interdisciplinary knowledge and you can retake the knowledge from everywhere whenever you want. So now the era of learning, the cycle of learning has reduced from decades to the month. So the first previously you were used to have a knowledge in a 4 or 5 years of degree program that now in this era you are supposed to have that same knowledge in a 6 month course or 1 month 1 year course, right? So first of all this aim, the FDP's aim has been shifted now. So it ensures that faculty members are not merely keeping the pace with these changes, but they should lead them, right? So here the XLR has created a bridge between the foundation pedagogy and the frontier technologies. So this FDP empower educations to translate some little bit of complex concept. I would not like to say a complex, but I will say a little bit of complex concepts because I am a Terran itself, so I can't say this is a complex concepts. So complex means like quantum mechanics, we will be talking about more in the as we move ahead, move to the courses. So this circuit models, algorithm, quantum advantages, all this everybody is talking about. So this into the turning into the meaningful learning experiences for the students, because I would like to all of you to call it as colleagues. My colleagues are there, so everyone who is joining like a colleagues. So they should use this FDP's knowledge to transform the new generation of the students. So at least so it's a very good province are there. When teachers are updated, the students are uplifted. When faculty evolves, the institution transforms. So this is the aim of the FDPs. So you just take the knowledge, you just enhance your knowledge, accelerate your knowledge, provide this knowledge to the next generation. And whenever the batches of the generations are evaluating from colleges, different colleges, then the institution transforms. So this is the real strength of the FDP. So with this knowledge, we are entering an era where this emerging technologies are reshaping the education. The reshaping means to say that this lot of speeding technologies are there like AI, machine learning, quantum computing. You can say heavy words, clouds, IoT that having a good gravity, advanced computing. It's like a good gravity. Hearing words looks like words. So for the first time in history, so as we will come to the quantum computing, so I think from the last 4 or 5 years, I am just experiencing that from last 5 years, I have shifted from that this corporate field, and but as I am turning back and looking towards the academics, so I am just feeling that this is the first time this quantum computing courses. This is the first time the students are encouraging and encountering the technologies before the textbooks are even written. So textbooks, there are not so much textbooks. So you can say there are very rare textbooks. There are lack of textbooks there. Okay. So the textbooks are even not written, but you are encouraged to give and to provide the new course to the students. So it's a very good challenge and very challenging challenge for the faculties how they will provide the things which are not quoted in the textbook itself. So that is the real challenge of the quantum computing, because whole quantum computing is based on the physics, uses the language of mathematics, and performing the electronic circuits and giving the results in the algorithms. So this is completely interdisciplinary things. So if you are from the EC background or from the EE background or from the CS background, so every faculty will have some problem in some areas. Either they are having a problems in the going depth in the physics, or they are having a problem going depth in the hardware. So somewhere, some corners, every faculty is having a problems in this course, quantum computation, as long as they are get involved deeply with it. So that is the aim of this FDP, to encounter these problems and giving the acceleration to you to provide the new encouraging encountering technology towards the students, give the students. So emerging tech demands a mindset. See what happens whenever we ask not only what to teach, but how to teach. See what has never been taught before. So this is the real ambiguities. So higher education must therefore embrace, I would like to say, that interdisciplinary thinking. So what should be imparted in the students, always, as well as to the faculties also, the interdisciplinary thinking. Okay, you have to give the students the interdisciplinary thinking, conceptual clarity, the computational reasoning, and hands-on experimentation. Why I'm saying this interdisciplinary thinking? So just go. This is not the world only. It is interdisciplinary thinking. It's not that I have copy and paste it from the net. It's just go beyond these wordings. Why the discipline? Suppose any CS faculty is teaching to the students of CS, right? So he's generally he's teaching this course in detail. I think in the third year, second or third year. So he is supposing that students has learned the concepts of computer, and a student is also having the mindset that he has created the uh, whole section into the only and only computer. Now there is no relation with the physics, or let me bygone with the first year physics, mathematics. Okay, only these are the part. This I know only. Okay, so these are the mindset of the student also. So we have to come out of this mindset. So no, that now we have to say, while teaching this course, we have to say that no, this you have to concern with the physics, you have to concern with the life, our daily life of examples of that. So coming out of that frame, suppose if you are teaching now from the faculty point of view, if the faculty is teaching the CS, suppose you are teaching a C++ or programming, OOPS program, or data DBMS like that. So you are understanding that at somewhere, some corners, students are setting their mind to having this logical thinking only. So because CS is only about this logical thinking. So faculties also sets a trend in the 20 years teaching that, yeah, so if I am teaching a CS, it means the students having a logical mind only, and rest of the setbacks they are not getting. But faculties also, they have to come out from this thinking that now let them free to think in the field of everything, either is in physics or in the, if so the student will naturally will ask the questions from the physics, naturally they will ask the question from the mathematics. And faculty, now there is a challenge for the faculty. So it doesn't mean the faculty may have all the knowledges from the physics and the chemistry and all these things. No, we can't expect that, right? So what is the solution for this? So we cannot overburden the faculty by having all these knowledges. We cannot overburden the students by having all these things or restricted in a one field. So the solution of this, what I'm thinking, that solution is this: rather than considering the students them as we are considering in the conventional courses from the last 23 or 40 years, don't understand the students them, understand that both of you are moving ahead simultaneously. So this is the solution. So and this is a suggestion from my side to all the faculties, that while teaching this course, understand that, and you have to convince the student also that all these courses, this quantum computing at least, we both are moving ahead in a same pace. Maybe the faculty may say that maybe I am having a 20, you are having a 19, only on that things. There is only a little gap between us. So you just ask the questions. We will try to handle these questions. We will try to go in the depth of that question. Then we will solve combinedly. So I think the initial concepts, there are nothing to worry about that. So this worry is when we are going to implement the project. We are going to implement the circuits of the quantum. So then the worry will come. The circuits demands a depth knowledge of this mathematics, depth knowledge of logical reasonings, depth knowledge of physics background also. So this is the ultimate aim. So that is shift from content-centric teaching to discover-driven learning is where the future lies, right? And at the last, I will try to say this: there's nothing is possible without the industrial collaboration. So just have an eye on the industrial collaboration, because all of your faculties are from the academic background maybe. So just have the eye on the industrial collaboration. Whenever you are having a chance, go to the industrial collaboration. Either there are IBM working, there are a lot of new national quantum mission has been launched. So they are emerging, new companies are emerging, startups are emerging. Just have a look at the industrial collaboration, because they will give you the real world problems. So the current tools, the workflow, the emerging skill expectations, they will tell you that this is the skill expectation. This you have to train your students. So like that. So with these wordings, I will say that no single university, research lab, or company can drive this field alone. So you have to take the collaboration. So progress happens only when this academia, startups, national labs, global industry leaders work together. And that is why the FDP is like this one. So hosted with the industrial partnership, this XLR, academic outreach, and these are the essential pillars, right? So it ensures our faculty, institution, and our students so grow in the same alignment with the world's leading technologies trajectories. So your commitment to lifelong learning is what keeps the spirit of higher education alive. So I want to say this: the future, whether the quantum, AI-driven, or interdisciplinaries, will be shaped by the educators like you. So in the end, I just want to thank you, XLR, for creating this platform, and thank you all for giving me this opportunity to address you. I will be looking forward to exciting dialogues and discoveries this program will spark. So have a wonderful, inspiring this FDP ahead. So now I would like to end my this speech. So yeah, so over to the Nitya.
Thank you, Vipul. Thank you very much for that note on the quantum computing. So let me hand over the session to Mr. Amar Shivate, who will be doing the complete LMS walkthrough, after which the session will be handed over to the to Mr. Vipul Saxena.
Back to me.
So over to you, Amar.
Yeah, sure. Thanks. So, dear faculty members, once again, very good afternoon and warm welcome to the FDP by XLR on quantum computing. So, I'm here to give you the quick walkthrough onto the LMS portal. So, it will be part of our journey, not only for 5 days, but it will be there with us for next 1 year as well. You can access the recordings, you can access the material. Okay. So, LMS is nothing but a learning management system. And by using that, we are going to provide all the documentation. Even you can join the session from LMS portal. You can access your attendance from the LMS portal itself. Even you can watch the recordings, you can download the required material, or else you can view the material from the LMS portal itself. Right? So those who register like till today morning, so the LMS access are already granted to everyone. So at that time, you receive one email confirmation as LMS portal account details by XLR. Okay. So if you're first time user of XLR, you received another 2 emails. But if you already attended any previous program, FDP, okay. So in that scenario, you received one email that is a welcome email. Okay. So by using that directly, you log in because you already have your login credentials with you. So by using these details, we have to do a sign in, and here you can check your portal link, email address and password. So the portal link is nothing but the LMS URL, mylearning.xla.com, email address, that is your username, and the password, that is the system generated password. It's little bit lengthy. Okay, so I will give you the idea as well once we are going to do a sign in. So how you can update your password. Okay. So let me reshare my screen and will directly proceed with the LMS login via Chrome itself. Okay. So whatever the browser you are using, any of the browser. So I'm using the Chrome, so I'm just opening the Chrome. I'm just opening the new window. Okay. And here I'm typing the mylearning.xla.com. So this is the LMS URL. Okay. So you can check here. Once I type the mylearning.xla.com, I'm able to see a couple of products here. Create account existing user as a login. So whatever the product you are able to see here, that is XLR and government initiative for credit-based courses. Okay, so here you have to proceed with that as the existing user login. Okay, and whatever the password and your mail ID you receive by XLR LMS portal, so you have to use that. You have to provide that details, and you have to click on a sign in. Okay, and as I said, that couple of you are already having the LMS access because of you already attended a couple of FDP program. Okay. So in that scenario, if you are unable to remember the password, no need to worry. You can just use this option as forgot your password. Once you click on that, provide your registered mail ID and you will receive an email. Okay. Just forget the password and you can just go ahead again and sign into to the LMS. So let me go back. So once I provide that it is successfully, I will click on to the sign in. Okay. So once I click onto the sign in, it will take me to the dashboard. Okay. So here you can check, I have option of bank to home page, community, leaderboard, purchase history. If you're looking for any help as well in the future, you have that help button as well here down. You can type your query. So our team will be receiving the email and you will get the help on that part as well, whatever you're looking forward in the future as well. Okay. So now, as I said that you can update your password or you can update your profile. So how we can do that? You can check here to the top of right corner. Here you are able to see the profile option. I'm clicking on the profile and I have setting option. Okay. See, so from here I can update my entire profile with the full name, username, mobile number, photo, and here only I have an option to update the password. So you can come here and you can update the password, whatever password you want from yours. Okay. So here is how you are able to update the password visiting. Earlier I'm on dashboard. I clicked on the profile and then setting, and you can update the password. Okay, so we're done with the profile, we're done with the help. So homepage. So as I already explained that the community, we're not required to do anything on the community. It's not live for this program. So leaderboard. Okay, so a leaderboard, I will just give you the quick walkthrough on this as well. So as XLR is providing the different training program in collaboration with different universities and colleges as well in Pan India, right? So we are taking some tests on coding test or MCQ assessments or assignments. So according to that, the student submission, the students will be receiving the XPs and the toppers will be printed, will be showcased here as a leaderboard. Those were toppers. And then below the leaderboard, you have a dashboard option. So this is a very important option. So on a dashboard itself, you are able to join the live session. How you can check here, you are getting one live session today pop up, right? With the red blinking dot. So you can just check here FDP on quantum computing day 1, December 8th, 3 p.m. Once I click on that, I will find the two links. First of all, you can see here, join a Zoom meeting. You have a Zoom link with the meeting ID and passcode and your YouTube. Once you click on the Zoom meeting, it will take you through the Zoom. You can join the session from the Zoom. If you're struggling anywhere while joining the session from the Zoom, no need to worry. You can just click on the YouTube link and it will be live onto the YouTube as well. So YouTube participant, just one information would like to share with you. So the things which happening over the Zoom, all these things similarly lie onto the YouTube as well. The links, if you want to download an application or the attendance link or the registration link or any details which we are sharing onto the Zoom, that will be shared on YouTube as well. And make sure that if you are having any query on question on YouTube as well, just click onto the live chat, you can post there, our team will take care of that. Okay, so this is how you can join the session. And now we'll move forward with how we can access the recordings, material, attendance, that things, right? So enroll courses, you have the second option, that is enroll courses. So I have 88 enroll courses, but as per your registration, you are able to see that courses on your dashboard. Let's search for this particular program, FDP on quantum computing. I am opening that. Once I open, first of all, I will find the agenda. In agenda, I will get to know that, okay, so what is the plan for next 5 days and what we are going to learn on a daily basis for 10 hours. Then attendance and feedback. Here you will find the link. Attendance and feedback is a very important part again. So to get the certificate of participation from a team of XLR and collaborated colleges, 60% attendance is mandatory. Okay. And just on top of it, one more information. Please use the same mail ID for all the 5 days to submitting your attendance and feedback. Same link, the link which is available over the LMS portal will be shared over the Zoom and YouTube chat as well, sharp at 4:30. And the link will be active in between 4:30 to 5:30 p.m. for that similar day for 1 hour only. So please take a note of this and follow these things because it's important for the certification. And again, we're looking for the valuable feedback from your side about the program. Below the attendance and feedback, I already explained about the live session, how you are going to join. That tab is available here as well. Then day-wise recording, you will find here day 1 to day 5, all recordings will be available here. And the material. So as of now, there is no any material available. But for all 5 days, the material will be available here. Yes, so this is how you can access the LMS portal. I hope things are clear. If any doubts, any query, any question, you can post into the chat box. Our team will take care of that. Thank you. And Nitya ma'am, over to you.
Thank you, Amar. So I would like to hand over the session to Mr. Vipul Saxena, who will be taking it forward. Over to you, Vipul.
Okay, thank you, Nitya. So, yeah. So, so this now we are starting our session here. So, first of all, I will like to introduce my philosophies and things, how we are going to ahead in this course, and what are the because every person, because I am the trainer here, so you should know how I am aspiring with this quantum computation and how I entered into this field. So this is as you are knowing, this is Vipul Saxena. So my academic journey has been rooted deeply in physics and material science, and I completed my masters in physics basically, and then specialized and enhanced my this physics into the materials engineering, having a master's MTech degree. Then I again gone to the PhD from the IIT BHU in the materials engineering. So over the years, I have worked across a lot of advanced materials. So materials means to say hardware, because materials we can take it hardware. Okay, so quantum scale behaviors I have worked it, and the technologies that bring physics and computation together, right? So, my interest in this quantum computing naturally developed from my background. So when you work in physics and material, quantum mechanics becomes a language you think in every day. And this quantum computing is one of the most exciting ways that physics transform into the real technology. Actually, and during my journey, I have forgotten this quantum technology. I only studied in my master's when I did in 2005. So, but I return in it because the era was now at the quantum, working with the quantum. Then I just turned back, returned into this quantum field. So I primarily teach you the quantum computing and quantum algorithm, focusing on building the institution along with the mathematics and computation clarity. So as I talked about that mathematics, we started from the physics, we are using the mathematics, and finally concluding on the computation, right? So across the upcoming sessions, we will start from the fundamental of quantum mechanics and gradually build into the move forward into the qubits, quantum states, quantum gates, and all of these things, quantum circuits. So there are varieties of the quantum circuits. So we will move on that. Then we will be discussing important algorithms like Deuce algorithm. So that is a fundamental algorithm which has proven this quantum concept. Then Grover's search and Shor's factoring algorithm. And because of these two algorithms, they are making a very much noise in the quantum, in this IT world. So not just how they work, but why they work. So that is the most important. As a faculty, you should know that why they're working like this. Okay. So there is a magic behind these algorithms. So the most fundamental things are that, but that is basically based on the some physics principles, right? So we will try to mimic these algorithm along with us our daily life also. So what are the magic when we are implementing this algorithm in our daily life? Because my intention always towards the faculties are like that, because I had been also a faculty. So we can give the students to a very good fascinating things if we are able to get it in our mind the examples only. So we will work around the examples like that, and then I will also want to have that example session as interactive. So along with the theory, I think so we'll also get a hands-on experience using Qiskit to simulate the circuits, understand how the programmings, the quantum programmings, so-called, are actually built. So I like to make sessions interactive, but due to some restrictions, because of restriction, that everybody should have when if the restriction is mute, all of you should remain on a mute, because there are a lot of faculty members. So if we are unmuting one of two of them, then the noise will able to disturb all of the faculty members. So only this is the restriction. Otherwise, please feel free completely to post your queries anytime in the chat. And at the regular interval, whenever I will get eye on that, then I will respond time to time. Okay, or that queries. So please don't hesitate. Even a small question can help the whole class understand the concept better. Because I am having a one mind here, but I think I am running with the 500 minds. So the question can come from any mind, and maybe possible that question is will be so much important. So it will enhance all the 500, including me, the this pace of this quantum FDP. So what you will get in the end, a strong conceptual foundation in the quantum principles, clarity on how qubit and quantum gate works, ability to understand, analyze quantum circuits, then hands-on experience using Qiskits. I think you will be getting a that's a content list, and the confidence. This is the most important to introduce this new quantum computing in your own teaching or academic work. So I would like to thank XLR again to this session, and thanks all of you for joining. So I am very excited to begin this journey with you. So let's work together to make quantum computing simple, intuitive, enjoyable. Not only from my knowledge, I will also want to include your knowledge. You are free to text your things in the chat box. So maybe your thoughts are so much, so much. Maybe that will be so much encouraging to give a shift to this all the 500 faculties. So everyone, so as I said that I suggest to you, so same I will follow here. When I am suggesting you, you just start with your students and making and go ahead with the simultaneously. So I will also saying this. So I'm not teaching here, not going giving anything else here. I'm not anything different here. I'm only conversing with you, all of you, and just having expectation that you will come along with me with these conversations. It's only a conversation and debate point of view. Okay, so let's start with some basic things. So I'm just sharing a PPT along with you. Okay, wait for a minute. So sharing. So yeah. So before we go to the quantum, these are the very very famous things you are knowing everyone. So, but there is a formal things which I have to introduce for the first slide. That computer is a programmable device, performs arithmetic and logical operations. You know, everybody knows this. Includes memory, processing units, control system, and all the operational flow. Right. So the processor runs instructions to read, process, and store data. Right. So this third line is a very much important. It's not the line. It's not the line. It has a very much special meaning in this quantum. Because we are going to change this definition. The process runs instructions to read, process, and store data. Right. So this reading we are going to change here. This processing we are going to change here. Not in the classical computer way, in a very speedy way. And this store data. So that remains the same. But this reading and processing, we are going to change here. So the processor, the classical processors, run the instructions to read, process, and store data. What it means? It means that if this classical computer expert or any algorithm expert, well, they are designing the algorithm C, C plus or Java or whatever. So if they are designing the algorithm, means they are not providing a solution. It only simply meaning this. The processor runs on the instructions. So we are not the solution provider. We are not providing a solution. We are only making the algorithm, means we are only making a pathway, what pathway we have to follow. Only that one. Who and then who are making these solutions? The solution making are the fundamental science educators. Because in the algorithm, what we are doing, we are following some formula, right? we are inputting in our IT and all these fields, we are inputting this formulas to our algorithm. So that means who is discovering the solution? The solution is discovered by that formula only. It is not discovered by us. So just remove this ambiguity. That's only we are the path guider, okay, in the algorithm. And that algorithm we are going to change here. So just please focus on this point. We are only the path provider. What path it will go. We are not the solution provider. Okay. So then, yeah, from the hardware point of view, I have to say, everybody is whenever we are working on the software side, everybody is forgetting this corner that computer evolved from the mechanical devices. So from the vacuum tubes and now lead to the transistor-based system. So it will have also the importance why we are developing the quantum. So that means, have you heard about that before the 50 years or 40, 50, 60 years ago, or even the more ago, we are having a very bulk size of computers that is occupying the space of 2 or 3 rooms. That is the very first computer has been made, right? So that is called the calculating things. Okay, it's not the computer, it's for the computation and the calculations of the simple calculations. So, so from that large level occupying space to this modern uh, tablets space to laptop space, we have traveled a journey a lot along this 50, 60 years. And in this journey, there is a one law which is very important that is given by the Intel founder. That law is called a Moore's law. Everybody knows about that. So we are the faculties, so we are teaching these laws. Okay. So I will not talk about more about these laws. I will talk about how we are connecting these laws into the quantum. Okay. So that laws, because of that law, Moore law, it is actually not the law, it is only the statement given by predicting the future age. Okay. So he has not made this law, but as the evolutions were going on into the technologies, he has predicted that, oh, every 2 or 3 years, we will shift into the another things. So the shifting is, everybody knows, the number of component in the ICs we are doubling, and reducing the size of the ICs. Only that Moore, the foundation, the founder member of the Intel, that working on the Intel also, that is only predicted that once. That was not the law. But yeah, that law coincidentally, as the thumb rule he has presented, but coincidentally that has now proven very realistic. That in every 2 or 3 years, we are getting the number of components in the ICs double, and we are getting the reduced size of ICs in every 2 or 3 years, right? And that's why how we are traversed the journey from the large space vacuum tubes to this transistor-based systems, right? So, so the modern computer use transistors fabricated through semiconductor lithography, photolithography. Okay. So this is how the classical. Okay. So now we will talk about more about uh, relation to the physics, but in a philosophical way. Okay, because these are the foundation things which we want, that when we are going in front of the students, then every student will certainly ask that what is the need of the quantum, why we are developing this quantum, and how this quantum concepts or quantum ideas has been leading this here, like this. So I'm just trying to give you some my as per my understanding to these ideas. Okay, I have created these slides as keeping the mind of you of my perceptions. Okay, so all of you may have are free to ask anything in this. Just to think philosophically, if we are thinking philosophically, the classical era. So the universe as a perfect machine. So it was begin to think in the 18th, 19th century science. So that universe is fundamentally very deterministic, a continuous and predictable. So deterministic means if we are able to say that presently any particle or any vehicle having this motion, the state of motion we are predicting velocity we are predicting and state it is I think. So we can predict its future also. So that means everybody knows because everybody I think from the science having a different streams, but they are having a science stream I know. So everybody knows the this Newton's three laws, right? So that is equation of motions. So that equation of motion is enable us to determine the future. That means V is equal to U plus AT. 1 minute. Yeah. So that is V is equal to U plus AT. So what is this? This is the initial velocity. So if we know this initial velocity, we can know the final velocity at certain t time. So if we are free to have this compute this velocity, now I will start using computing. I will not start using evaluating computing, right? So if we can use to compute this velocity after t time, so that means we can have this velocity after a 1 day also. That is 24 hours. We can have this velocity even 100 years also, right? So we can have this velocity even at 500 years also. So all these equations, Newton's laws of motion, are enable us to say that our universe is deterministic. Deterministic means we can determine the future, right? So that we can determine the velocity, we can say 100% that after 100 years, wherever this particle will be. And keep in mind that we have included the condition of acceleration also. So if the velocity is going to change, we have that condition also in this equation. So that means the universe is deterministic, 100% deterministic, right? And it is continuous. Everybody knows about, there is no doubt. Okay. So I don't think so. It should need to be elaborate more. So it's a universe is continuous. It has a deterministic nature and it is predictable. Predictable means because we are using this equation of motion, so we can predict 100%. After 100 years, what are the states of motion of this object? We can predict. Okay. So that means that giving us the logic, that giving us these things, because this deterministic, 1 minute, let me remove these things. Because this deterministic nature has enabled us to give in this logic. What the logic is there? 0 and 1. Because world is deterministic, that means either we can say either there is a yes or no. There is a no or yes. So this deterministic, we can rather represent in a bits, that is 0 and 1. That's a logical steps, and there will be no ambiguity. So either the particle will be present there or not. So only there are the two possibilities as per the natural scientific way we are seeing. Okay. So that makes the concept of logics Boolean algebra, and that is 0 and 1. Okay. And that this logic we have taken away taken ahead in the classical computation. Okay. So what the thing is that belief at that time was that observation does not disturb reality. So just make a punch of this line that observation does not disturb the reality. So after 100 years, if we will measure the velocity of something, that will not give, yeah. So that will not give this anything disturbing nature in this velocities, right? This was the belief in that era. So now, universe as a machine, it has presented a model. So misbehavior. So from in the 18th, 19th century, it was belief, and the nature starts misbehaving when across of nature. Plus 1900. Okay. So in the junction, that is 1880, this black body radiations, photoelectric effect, atomic spectra, and double slit experiments, right? So all these are the main culprit of this deterministic nature. So all these phenomena are suggesting that somewhere, some corner, the nature starts misbehaving. So what are that corners? What are that the things where the nature starts misbehaving? The things are that when I'm not going in so much detail, okay, no worry about that. Only I'm just connecting these things. Connecting means we will touch the surface only, okay. So not go because you have to convince the student also. So so as what are the corners where the nature starts misbehaving? So corners are like this, that the things are that all these phenomena are pointing only in a one direction, that whenever we are going in microscopic world, we are going in a macroscopic world, so they are starting misbehaving with us. So what the misbehavior is that? The misbehavior is that it will interfere with the some microscopical things. So these macroscopical things like whenever we are going in the black body radiations, photoelectric effect, that electron coinciding with the photons, so like that. So that was the misbehavior of the deterministic nature. So this misbehavior is the leading pathway to have introduced the quantum world. So in the 1900, exactly in the 1900, the Planck was working on the quantum technology. So he has proposed some thesis. Everybody knows that hypothesis. That hypothesis was that the light was composed of bundle of photons, and he's having an energy of h nu. So he was working on this concept. So whenever Einstein was the first one to think about that. So can we implement this concept? Although that was not proven that time, it was the only hypothesis. So Einstein was the one who have implemented this to explain the photoelectric effect, this phenomenon, this hypothesis, and he has successfully explained this effect, photoelectric effect, by introducing this equation E is equal to h nu. Not going in so much detail, only this is sufficient to convince the students. So, and I will add this line. This Einstein has received the Nobel Prize for this photoelectric effect. Okay, so he has solved the very intense problem at that time. So everybody may think that Einstein has gone related to the theory of relativity. No, he has not received the Nobel Prize for theory of relativity. He had received the Nobel Prize to explain the photoelectric effect. Okay, so this Planck has introduced this theory, and we that when Einstein has successfully explained this photoelectric effect by using this theory, then it has become a theory. Previous to this, it was hypothesis. Now it becomes a theory. Okay, so this Planck theory has been originated in the 1900. So yeah, so mm, moving to ahead. So now there is a quantum computing born from impossible questions. So I have tried to include these questions here. We will try to uh, answer. 1 minute. Let me see. Somebody is. Yeah. So the very first question: why can't classical computers simulate the atoms accurately? So this is the very question will come in mind. From this point of view, I'm talking about that because we have to entertain the students also. So very first question, it will come into the mind, why can't the classical computers simulate the atoms accurately? So because it should not be the answer for that. I have written an answer because classical physics is not the quantum physics. So this one line answer, it cannot work, but yeah. So, but as a faculty, you can have this answer. The classical physics is not equal to the quantum physics, as I stated in the previous slides. Why? Because we are going into the less microscopic phenomena, and in the macroscopic world, the things are starts misbehaving. Okay, because of certain phenomena. That phenomena, the black body radiation, all that phenomena are enable us to think differently. And this Planck has thought differently. So yeah, the question lies on that. So the second question, what computer followed a quantum rule instead of the classical logics. So that is the right spark, and that is given by the famous spark. I will talk about in the next slide. Yeah. So, but that will be a question. What if the computer followed the quantum rules instead of classical rules, classical logic? So, whenever you will say to the students that see, classical physics doesn't having a equal to the quantum physics, so a student will 100% student will respond like that. That yeah. So okay, no problem, no problem. The classical physics will not follow the quantum physics. Starts me, but yeah, we have the rules of the quantum physics now. The rules is this. The rules is governed by Planck. So we have the rule for the quantum physics. Then naturally the question will come from the student sides also, that what if a computer follows the quantum rules instead of the classical logics? So the same thing is sparked by the Feynman. So Feynman also thought in this direction, and that thought started the foundation of this quantum computation. Right. Yeah. So you can answer yes, absolutely. So we have to think about that. And because of that thinking, we are is now at this point that we are developing something in the quantum. Right. So the next question, can such machines outperform the classical ones? Yeah. So that is answered by after the Feynman has taken a spark in that field. Yeah. Can we enter this quantum rules? So Feynman has answered this one. Yes, we can enter in the quantum world. So then can such machines outperform the classical ones? So there was a concept of the Turing machines. If I think most of the faculties from the computer background, they are knowing about the concept of the Turing machines. So that Turing machine was the hypothetical one at that time, right? Until now. So it was a hypothetical machine. So which used to answer the things, used to solve the problems, but only in a hypothetically. So only in a mathematical models like that. Okay. So Deuce was the very first to answer this. Yes. That can such machines outperform the classical ones? Yes. So the during the Turing phenomena in the Turing machine, there was a theory that no, that there is no such type of problem we can we can we cannot solve in the computer. So there is no such type of problems we cannot solve in the Turing also. So the Turing thesis, this is called the Turing thesis also. Actually, the theory, this Turing machine theory has been proven wrong by this Deuce. So now just have the punch on this line. This is the starting. This is the starting. Before this slide or before these two questions, the initial two questions, I'm only talking about classical world and physics world and like that. So if you are from the computer science background, now that starts from yours. So this is the starting point of yours. You can take the spark from this question that yeah, can such machine outperform the classical ones? So we can overcome this Turing machines limits. Yes. So Deuce has proven this by using some algorithm. So we will talk about this algorithm also. So the starting punch will be yes. Yeah. So who was the person? So Deuce was the person to answer this universal quantum circuits, right? And he has given the algorithm only to prove that yeah, there is a quantum supremacy over the classical ones. So only Deuce has given the conceptual things, and to yes, we can solve this one, or there is a problem where the classical computer cannot solve, and yes, we can solve by the quantum. So the Turing thesis has been proven wrong by the Deuce that time. So, but if a student will ask, yeah, what is the application of the Deuce? So there is no application of Deuce as such. So we will not use in a daily life. We can find a very rare application, or in a 4 or 5% cases. I will say I have come across only 1% application of the Deuce, right? So Deuce algorithm only to proven this concept of quantum supremacy over the classical ones, right? So the next question, this is a very important question. Can quantum machines solve the real world problem faster? So when the Deuce has proven this concept that yes, Turing thesis is wrong, yeah. So when the Turing thesis has proven wrong by the Deuce, now there is a time to move ahead. So the time to move ahead means this Tuse has given in 1985. So this feminist spark was in 1980. That now in a 1992 to 95, there is an era of Shores and Grovers. So go Shores and Grovers that has found the real world problems that is faster. So Grover has found the problem of unsorted data, and the Shores has found the problems of this factoring problem, right? So factoring problem, in fact, is a very, very magical one. How we can factor. So Shore has given a theoretical concept of that that's converted into the quantum way. Okay, so that were the questions from students may interact at the time of studying the quantum computation. So now we will talk about now. So that was the from the point of view of how you have to interact at the initial level when you are introducing this course to the students. Now this classical computing hits the fundamental limits. Now we will talk about this, okay? And from that, a student will start taking the interest, right? So naturally they will ask, the classical computer hits the fundamental limits. Yes, they will hit that fundamental limits. So the limits are now that. So what are the limits? So limits, as we were talking about the Moore's law. Okay, I'm not talking about more because I know all of you are the faculties. You know very well what are the Moore's, and you know very well how to teach the quantum. I know. But yet, yeah, there is FDP. So I need to discuss these things. So maybe some of you may be greater teachers than me. Some of you may be greater, having a greater knowledge than me. They are having greater research than me. But yeah, so I have to take in these things. Yeah. So, but yeah, at the same time, there are the possibilities that new joiners are there who are introducing this course to the new faculties are there who are introducing this course first time to the students. So they may have got things. So yeah, overall, this is the aim of the FDPs. So I have designed this FDP only by taking this thing in the point of view that how our faculties are going to interact. Because when I going to interact with the students, although now very less ones because I am in this industry side. But yeah, I'm going to interact with the interns also. So a lot of interns are coming to us and saying that we don't have the background of quantum, how we can understand this like that. So that experience I have included in this. Okay. So yeah. So now we are moving with the fundamental limits. So yes, this Moore's laws has set the limit. What they set the limits? So to elaborate more about that, because teaching is more about the examples. I can give you one example for that. So example is that suppose we are living, every students are living in a hostel. So suppose we are living in a room. So 1 minute. Yeah. So yeah, some of the students, no, some of the peoples, not students, some of the peoples are raising their hands. So I think you can type your questions in the chat box. So I will get a time, then I will respond. Okay. So no worry if there is no interaction, no worry. I will have these questions in my mind. So there is a session of 5 days. So I will have that questions in my mind. So maybe in my speech I will involve in such a way that it will tackle your question. Maybe it will not give you a perfect solution, but it will tackle your question, right? So 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 yeah, Moore's law. I'm just about to give you the examples for that Moore's law. That suppose the students are living in the room. Suppose in our room, the room is like that. We are supposing room as a IC. So suppose there are two people only living in the room, like. So there is a rule in the BTech also. So in the first year, the 3 or 4 students are living in the room. So as the year passes, second year, third year, fourth, that. So the 4 students are living in the first year, 3 students living in the second year, 2 students living in the third year, finally in a solo, right? Right. So that I have found the examples from that also. So suppose the students are living in the room, and when the 2 students are living in the room, so they are very free to set up their computer table. They are very free to move ahead their hands. They are exercising, doing the yoga daily, right? But what will happen? What will happen when you will increase the density of the peoples in the room? Suppose you are increasing 10 peoples. So whenever there is a 10 peoples in the room, the students will feel hard to move their hands also. So whatever what happens when we will supply hundreds of students at a time at this room, they will tighten their space, and even they are unable to move their hands also. If they are until if they are going to move their hands, that will disturb the other people also. Okay. So I think all of you are very understandable ones. So all of you have taken in the right directions. Yes, we are talking about the ICs also. That number of components we are doubling in the Moore's laws, right? So as we are doubling the number of components, so when we are doubling or like that in every 2 years number of components, so that means we are providing a less and less space to the moving the hands, right? So the moving hands, like we are operating the transistors or diodes, whatever that hardware is made up of, right? So it is on and off state. Everybody knows that we have to go to toggle to the on and off state. If it is in off state, we have to go to the on state like that. So when we are doing like that, so there is a problem. 100% the problem will occur when where we are going in on and off state, right? So how we can simulate it here? We can simulate it a funny example. So he wants to go in off state. So off state means he want to lay down. So to lay down, he needs a very good much amount of space. So he will not able to find out, right? If he's laying down, he will disturb the two or three more peoples, right? So the same thing will occur like that if we are increasing the number of components. So that problem only we are talking about from the point of view of increasing the components. But Moore says that, and that has gone right. Moore says that not only the number of components we are doubling, not only the number of components we are doubling by the factor of something, we are simultaneously reduce the number of the dimension of the room also. So when we are simultaneously reducing the dimension of the room, that means that problem is now more and more complicated. It's going to be, right. So the both of the things are going simultaneously. So it will give you a problem, and that means that means that now the days are coming from that micrometer or that micrometer. We move to the that suppose mm to we to move the micrometer. Now we are moving to the nanometer. So 100 nanometer, 10 nanometer like that. So now why nanometer? We are moving towards the Pentium series, P1 to P4, Intel series, and then we are moving towards the i3 series and i5 series like that. So in all the series, we are moving to the less and less dimensions, right? According to the Moore's law, yeah, the developing the things like that, semiconductor industries like that. So we are moving to the reducing the dimensions of the ICs. So why we are reducing? So this will be the natural questions of the students. Why we are reducing the ICs? Why cannot work in a larger ways? So we are because we want to reduce the size. No, size of the computer. No, we want to instead rather than yeah we can do this. We can also go that in that direction. Yes, but rather than increasing the size of the computer, we want to incorporate the greater number of components so the computation power get double or triple like that. That's why we are reducing the size of the chips, right? So that is the accurate answer for that. So when we are going to reduce the size of the chip, now the size of the chip has coming to the 10 nanometer size, right? So not only this ones, I Pentium to i3, i5 innovations, we are getting every year i3, i5, i7, every 3 year generation wise. That's generation 1, generation 2, generation 17, generation 15, like that. So what is the difference between that? Everybody can go on the Wikipedia page and can search out that is generation time, generation wise list of processor size, IC size, right? So the Intel processor size is reducing generation by generation, reducing product by product, and now it has reached to the level of 10 nanometer. So now this question is I'm going to give the solution for that. Yeah. So when we are reducing this 10 nanometer solution to up to this solution, okay. So after the 10 nanometer, now they are planning to launch it. I think so, maybe. So I'm not updated. Maybe so. Maybe they have launched or not. But before 1 year, I have listened that they are planning to launch 1.2 nanometer or 1.4 nanometer size of chip. Right. So even Google and IBM both are working together for this with the Intel also. So both are working together. They are going to launch on a very low size of chipping. That is 1.4 nanometer. So when we are launching this 1.4 nanometer, so now what will happen? Less than a 1.4 nanometer. So the very much less space will there, and the quantum phenomena will starts to misbehave. This laws of macroscopic worlds. So what are the laws we are governing? That current will go on and off and all that. That laws will misbehave. And the reason of misbehaving, I have explained here also, that here it will going to misbehave. So that is the point. That is the point. So before starting misbehavior, we have to start thinking about the futuristic technology. And this is the technology for the future now. So after the when maybe 1 or 2 years, or maybe they have launched this IC size. After this IC size, I think we are not able to accelerate our speed. We are not go on the GPUs and like that. Okay. So GPUs, what the GPUs? They are, yeah, you have any latest developed student can ask this. We are having a GPUs. Yeah, we are having the GPUs, but in the GPUs, we are using that the number of resources we are using to input the information. These resources are very much greater in the GPUs. So parallel lines we are giving, and the parallel lines requires a parallel hardware. So that's it. So it's like that. So we have uh, packaged the 10 Intel processors in a one packet, and we are providing this GPU like that. Okay. So it is not the solution for that. Okay. So by increasing the GPU, we are increasing more towards the space complexity. Okay. So that worlds, I think all of this computer science engineers and our faculties have dealt with these complexities, space and time complexities, big O omega, big O n square, okay, exponentials, right? It will involve that and that things. So yeah, this is the classical limit that hits the fundamental things. When this below than this 5 cents nanometers. So yeah, let me remove this all these strings. Yeah. So the quantum tunneling breaks the classical logic. So quantum tunneling, this year we have received the Nobel Prize for the quantum tunneling. So in the physics also. So the quantum tunneling is that I will like to uh, interpret this as in a one word that there is a wall. We are living in a room, there is a wall. And outside that, if some disturbance is there, some heat or some cold waves are there. So these heat and cold waves are not penetrating in our walls. Slowly they are doing the things, right? So what the quantum tunneling is there, okay, heat and waves, they are the waves, they can come, but any foreign particles are there, a small stone or something that will not come to us here. But in the quantum tunneling, this is followed by a leakage. It is called a leakage. In the quantum tunneling, whenever the quantum effect will dominate, so there are some percentage of chances. Okay, so how much percentage we don't know. It depends on the certain factors. Yeah, there are 5%, 10%, or 20% of 40%. There are some percentage of chances that there's a particle is there, the solid thing is there, but yeah, it can enter in this terrority even after having the wall. So nobody can believe it, but yeah, this is the logic of magic of the quantum. So the quantum tunneling says that yeah, we can break the classical limits. So this is the breakage of the classical limits. Okay. So this is how the concept is made in the quantum. So yeah, a minute. Yeah. So this is all about Moore's laws, quantum tunneling, and all that transistors reducing things. These are the fundamental limits we are getting in the classical computers. So suppose in the classical computers, so the quantum efficiency we can mark it. So 50 qubits, that is having a 2 to the power 50 states, 300 qubits. So more states than atoms in the universe. So we will talk about more of this. This is about the fundamental limits. So now, so this slide has covered my previous conversations. All that has covered this slide. So why the quantum computing? Yeah, to overcome all the limits. So the transistors are scaling saturations because of the size limiting factors. Uh, the massive parallelism, those that we are talking about, the GPU was that there in the conversation. So massive parallelism that we have to resolve that parallelism through the superposition in the quantum. So we will talk about the superposition more about that. So the operations, yeah, that is the fundamental one. How we can overcome, yeah. So that are the limits, but how we can overcome the quantum, this limit, yeah. So we talked about this. 1 minute, yeah. Yeah, we talked about this limits only, but we have not talked about how to overcome that limits. Yeah. So to overcome that limits, so this are operations are done at the atomic level. Okay. That are the very basic level things I am going to cover in this very first lecture. So what basic level things means every students and even the faculties are, because the faculties are not from the physics background. Because most of the faculties of the CS background, you have to taught this thing in third year or second year. They are lacking this information, not because of the intelligence. So don't take it as on your own personal level comment, not because of the intelligence, but because of the limits, how much you will study. Yeah. So yeah, if you have a time, you can go on the depth on the physics level also. I'm not having a doubt on that. Yeah, every faculty can go on that research because now everything is reported in the net, but you have to devote the time for that. So that's why. So that is the aim of this FDP to overcome that limits. And I will provide you the ready as per the my understanding. So all of you have 500 minds. So 500 understanding, I think the parallelly we are running. Okay. So yeah. So now the things are that everyone is curious about that, how we can overcome that limit in the quantum, right? So the limit is that we are going in the macroscopical level. So when we are going in the macroscopical level, it's a very cut to cut straightforward answer that yes, we have to do the operations at the atomic level, right? So whenever we are going to the microscopic level, yes, we have to do the operations on the atomic level. So we have to go in the atomic level because what is disturbing us? We are disturbing when the current is going on and off, and the macroscopic to microscopic we are going, then we are disturbing. So that means we have to find a way, what way, that we can control the things in the more deeper level. We can play the things at the more deeper level. Why I am saying this play that a more deeper level? Now you will get to know that in the classical computers we are dealing with the current. In the classical computers, what is the play? The play we are doing with the current. That is this current. Yeah. So a lot of questions are coming here. Yeah, just starts. So let me finish this thing. Then I will see some questions and I will respond. Yeah. So the current we are playing with the current here. So when we are playing with the current, that means current means flow of charge. Flow of charge. So charge means right. So exactly in the hardware level, flow of electrons. So this flow of electrons, that means this flow of electron, that means flow of electron means the electron is not we are calling a current to a one flow of electron. We are calling a current of 10 to power something 20 electrons or 10 to power 25 electrons like that per second. So this type of quantities we are playing with the current. So when we are talking about the current and 1 ampere, so we are talking about this quantity of this much of electrons per second, approximately. Okay, these are the approximate figures, not telling exactly. Okay, so we are talking about this of 10 to the power 20, 10 to the power 25 electrons flowing per second. We have to collectively control this flow of electron, and this flow of electron to control, we are always having a resistance, we are always having a condensers, we are always having an inductance, like that, the physical device, the physical components, that we can control this flow of electron. Even go ahead, we are having the diodes to control the current. Even that, go ahead, we are having the transistors to control that current. So semiconductor devices are mainly consist of like this, ICs, diodes and transistors. So we have the control on these things by having a diodes, transistor and MOSFETs, right? But here, when we are talking to going from macro to micro states, even then in the nanometer stage. So when we are going in so much details, so the current is, that's why we will talk about this. So in somewhere in the notes or teaching, while teaching this course, you may be hearing that this current is a macroscopic property. So somewhere we are writing this current is a macroscopic properties, right? So this current is a macroscopic property. So we're dealing with the macroscopic world. So when we are going to the microscopic world or nanoscopic world, so we have to change this macroscopic current. So now we will more talk about how we can control in the nano level. So in the nano level, we want to control, nothing is there to control it. There are only and only one component is that atom is there. Second, electron is there. So these two single electrons, we are talking about single. Here we are talking about collectively 10 to the power 25. Collectively, we are talking about 10 to the power 25 or 10 to the power 30 electrons that are flowing. So that means total number of accumulated electrons may be greater. So, but here we are talking about one atom. We are talking one electrons. There may be a Avogadro numbers of atoms in the 1 mole of the elements. That is the fundamental chemistry saying. So the Avogadro number is 10 to the power something order, right? So that are the number of atoms. But here we are talking about one atom only. We are talking about one electron only. So in a very precisely, in a one atom, what are the directions, the parameters to control this? We have to find out. We have to find out how we can control the electron here. Only a one electron. How we have to control. So this is the solution for that. When we are finding the solutions, we will be discussing more about this. So this if we'll go into the chemistry, in the chemistry, the rule is governing like that electron having a two states, that is a clockwise rotation and anti-clockwise rotation. So these two states, we can control the electron also. Either they are going in the clockwise or anti-clockwise. But answer, the question arises from the student side also. So sir, how we can control the clockwise and anti-clockwise rotation of the electrons? Yeah, so we cannot clockwise and anti-clockwise rotation of the electron. That is decided by the nature. But there is a one fundamental rule. There is a one fundamental rule that when this atom is placed in the magnetic field, there is a north, there is a south. So whenever this atom and electrons are placed in a magnetic field, then these electrons are aligning in some directions. The movement of these electrons, a spin movement, we can say, the rotation speed, that aligned in some directions. So this, now whenever we are knowing this rule of physics, so scientist has arisen a spark that yeah, now we can find out how to control the atoms in the microscopic level. We can control the atoms from applying the magnetic field. So we have resolved the one electron. We have resolved the one electron in a 4 or 5 states like that. We can control these states. The electron can be reside here, 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 and here. Or even then, even the more states may be there. whenever we are talking about 2 electrons or 3 electrons. So by combining permutation combination, maybe of good number of states we can have in the hardware side. Okay, and these are controllable until unless we are having the control on the magnetic field. So there is a one way to control. Now, as the development is going on, as the R&D is going on this side, okay, as I've said that even the textbooks are not there, so we have to glitch these informations from the different textbooks. So as the R&D is going on in this particular directions, so there are more way of controlling these electronic properties and the nano level scale. So we can have a better control on that, but that technologies are yet to be evolved. We will also cover these technologies in this fourth or third day of modules. Okay. So yeah. Yeah. So this Feynman triggers. So yeah. So what the original thought of this Feynman? The original thought that the nature is quantum. The nature has provided us quantum things. Okay, so why we cannot shift to the quantum? Okay, or we cannot shift our classical machines to the quantum physics. Yeah, that is the answer for the Feynman side. So they have triggered this thought, and this thought we have taken forward up to this time, 2025. So the classical simulation of the quantum, that is the exponential expensive. So this pillars, superpositions, entanglement. Yeah. So these are the things, that's existence of discreteness and continuity. So we will talk about this in this module. Yeah, what is the discreteness and continuity? That is a very basic phenomena things in this classical and this quantum. So yeah, so discreteness and continuity. So discreteness is, everybody knows about our de Broglie hypothesis. Okay, I will talk about 1 minute on this. That actually there was a quest for the nature of the light. There was a fight for the nature of light. So light was considered, sometimes was considered as a particle, sometimes it was considered as a wave, right? So firstly Newton has come. They said that it was considered as a particle. It's a corpuscle theory. Then de Broglie, so not de Broglie, that is Huygens has came and they're saying that yeah, it's a wave. Okay, but again, in the 1900, I talked about this quantum. This Planck had said that, yeah, light is a bundle of photon. So bundle of photon means discreteness he is talking about. He is talking about the discreteness. The bundle of photon having energy E is equal to h nu. H nu like this. So there is a struggle between the particles, then wave, then again we are returning to the particle side. So what signifies that? Then after that, this struggle has been stopped by the de Broglie. So on the first day, sorry for to saying this, on the first day, this whole session is looking like a physics session more, but it should be, but yet it should be, yeah, because it is a foundation thing. Physics principles, we are going to lay down the foundation of this quantum computing on the physics principle. So it should be looked like that. Okay. So yeah, I have designed in such a way. So yeah, so deep Broglie, because I know that you can tease these things, the computation things very easily, by taking the matters on the net. But the things we are talking about, this FDP, that will, I think, as my thinking, that it will enhance your capacity to tackle with the advanced students. That why we needed this quantum computing, what was the fundamental things in there. Okay. Yeah, so de Broglie has ended this struggle and fight between the scientists. They said that don't fight. Yeah, the electron, the particle. So firstly, he said about the electrons. The electron can behave in a both way, in a particle nature and in a wave nature. So in a particle nature and in a wave nature. So both has the different uh, this. So this wave nature is followed by the continuity nature. And this particle nature is followed by the discrete net nature. So de Broglie has said that if any electron is there, he may have the particle nature or he may have the wave nature. Both nature he can have, but at a one time it will demonstrate only one nature. Okay, it will like a diamond, like the things. Yeah. So in some in the wordings it was like called a baropia. So sometimes it will take a shape of the particles. Sometimes it can shape the take the shapes of the waves. Okay, so like that. So this so de Broglie said that. Then after that he has generalized this concept, and he said not only the electrons, everywhere in the world, everything in the world, moreover any particle can behave in these two waves, two ways, wave and particle. Okay, or when he talks about this, now this is the leading foundation stone for the quantum. Okay, so this was the foundation stone of the quantum mechanics. Yeah, the things can behave in both the ways, waves and a particle. So wave nature is dominating by the continuity. The particle nature is dominating by the discreteness. So yeah, let's have a look about more what is discreteness and continuity. So I'm going. My effort is to take in the depth of this whole course, because this course is lacking in the depth. That's why. So okay. So we will talk about the discreteness and continuity, because it is inherent. Discrete and inherent continuity are the inherent properties in the quantum. So we have to differentiate on this these property basis. Okay. So where the quantum is working on like that. So what is the discreteness and continuity? So everybody knows about. I will not talk about that, but only the two lines I have to say in this. The continuity means, everybody knows, continuity means there is a continuation from starting to end points. And the discreteness means there is a particle, because the particle is like the discreteness. And this discreteness and continuity, these both are the inherent nature. Just go on this punching line. Inherent nature. This discreteness is the inherent nature of this particle. And this continuity is the inherent nature of the waves, right? So I'm not going into so much detail, but yeah, I want to say that it is the inherent nature of the particle. So if we are considering something as a particle, means particle is that one. So just understand this bridging point. Okay, so this is a particle. So if I will say that this is a point A, and just in the vicinity of there is a B, there is a point B. So when the particle will move on the point B, we will say abruptly, suddenly we will say that if the particle has point A, then we are having a yes, 1. Okay, and at point B, we can say there is a 0. Okay, so just understand very deeply here. I want to convey this message. Okay, the intention is not to show the things, other things, but intention to having the connecting wires between this 0, 1 and discreteness. So so whenever the particle is moving ahead, so like that, the particle is moving at A. Suppose particle is at A, so we can form in the logically in the classical computer, we can say this is a 1 state, and at the particle B we can say there is a 0 state, right? And as the particle will move like this, so certainly he will jump. He will not go in the continuous. Certainly at the point of B, there is a B, there is a A. So certainly he will jump. As certainly you will say about this, yeah, the particle is going now at particle now at this point, particle at point B. So you will say at the point B, there is a 1. At the point A, now it has 0. So abruptly, sudden change. There is suddenly. So now you can say there is a discreteness. So this particle nature always following 1 and 0, then 0 and 1 path, then 0 and 1 and 0 path. Okay. So this particle nature is exactly what following 0 and 1, 1 and 0. Because discreteness is following 0 and 1. So between 0 and 1, there is a jump. And whenever there is a jump, you are always saying that there is a discreteness, right? So for one example, for the student point of view, okay, I am dealing all these things from the student point of view, but don't think and don't understand that I am understanding you as a student. No. I'm telling all these things that how to deal with the students. some of the faculties maybe knowing these things. Okay, yeah, but at the right time, right justification to the students, that is the key for the good teaching quality. So discreteness. So it doesn't mean I am a good teacher. It means I have gathered these things to communicate to all of you, right? So it depends on the sense of presence at that time. So what question is coming to our mind? Yeah, but I am preparing for that. So the discreteness. So the discreteness, we are always giving the examples for the students, 9th or 10th student level students. That discreteness is followed by the summation. This continuity, whenever there is a case of continuity, we are following a integration. This one, mathematically point of view. The summation, this integration. The difference between the summation and integration, there is a 1 plus 2 plus 3 like that. This is the summations. So that means we are jumping from 1 to 2, 2 to 3 like that. Okay, but integration, we have to do the summation of 1 to 2, 2 to 3 also. So that means we have to sum 1 plus 1.0, even 1.0001 also. So not even a single number or fraction of numbers we can leave out from the integration. So integration is just about a continuity. Discreteness is just about the summation. So like that, here 0, 0, 1 to 0 like that. So this discreteness, that's why I'm saying this. So you can note out this line also. The discreteness is the punching thing. So this is the inherent property of the particle nature. This is the very inherent property of the particle. And this continuity, this is the inherent property of the wave nature. Wave is continuous always. This wave is continuous always. So if we are now everybody can think about that. What is the relation at here? Yeah, the relation at here also that when we are saying that this particle nature, this wave nature are same, that means this phenomena are going from A to B. This phenomena was going from A to B. This phenomena, if you are talking about the de Broglie point of view, this phenomena, rather than going in this way, we can also take this phenomena in this way also. And when we are going to take this phenomena in this way, that means because it's a continuous thing. So we cannot take like this 0 to then jumping to the 1. We have to say there is a 0% possibility particle is not there. Okay. But whenever it is going, there is a possibility of increasing 5%. It's going here, possibility increasing 10%. Going here, possibility 40, 50%. Going here, possibility is maximum, that is 100%. So at the maximum, it is a possibility. Again, the possibility is going to decrease like this. So that's the how we can define the wave nature. So if we are taking the presence of the particle in a 0 to 1 in a discreteness, and if we are simultaneously, as the de Broglie is saying, the simultaneously we are considering this discreteness into the continuity as a wave nature. So if we are considering this as a wave nature, so that means this 0 to 1, abruptly sudden change of 0 1, we have resolved in these type of states. That is 0 to 5% to 10%, 50%, 20%, like that, 100% possibilities. Then we are going to decrease this possibility. Okay. I'm not defining this. If I think some of the students, maybe from the physics side, not the students or faculty, sorry, maybe from the physics side. So they are thinking that why I'm describing this in this way. Why I'm not describing, there is a very simple discrimination from the last 40, 50 years that, yeah, de Broglie have said this. There is a Schrodinger equation is coming there. So Schrodinger equation has said that, and there is an interference of waves. Yeah, a lot of waves are interfering like that. But no, I want to show this inherent properties of the continuity and discreteness. That's why, because nobody can say that the quantum computing is the compulsion. It's not the compulsion actually. Okay, so this is our decision. We have moved this compulsion after after exposing all the classical limits. This is our sequential mistake. We have made the classical computers. If we are following the nature, we have to make the quantum computation. That is the nature of the that is consisting the nature of the universe. This quantum. Okay. So when we are following the dual nature, that means same phenomena. If we are going into the wavy nature, continuous nature, so that means we are following in terms of increasing probability from 0 to 1, not the abrupt probability as the classical case. as a discreteness describing. Okay. So we can describe these cases 0 to 5%, 10%, 10%. Now, there is a question. Now there is a ambiguity is coming here. How we can describe the presence of something that we are talking about the presence of particle. So how we can describe the presence of something in terms of percentages? Because this line itself has the ambiguity that a person may have the presence of 10% only at some point. It's just like a jokey things, right? Kidding. We are kidding like that. No, but we are not kidding. The nature is just like this. So we are not kidding here. Yeah, we have to describe in this way that 10% possibility or 20% possibility, 50% possibilities of being there of the particle. So this is like a unconventional thing. The quantum mechanics is telling about these things, this magic, and this unconventional things that makes the magic everywhere. So this is the magic, that unconventional thing makes the magic everywhere. That how we can think about 5% or 10% possibility of being a particle there. How we can think about that? We cannot think about that 10% possibility of particle is there or 90% possibility of particle is not there. So if we are talking about the possibilities, that means from here to here, there are infinite types of possibilities. Like that, there is a 10%, 90%, there is a 11%, 89%. So you can form a set. So 10%, 90%, 9%, 80, 91%, like that. You can form the sets of all the infinite sets will be there, right? So all these sets, we are assuming as a quantum state. All these sets we are assuming as a quantum states. And from that, when we are talking about the being a particle there, when the particle 9% chances of being a particle there, 90% of chances being a particle not there. But we are taking this state. If we are taking this state, so we are calling this state as a superposition state. So this is the concept, how we are moving towards the superposition states, and this is the magic that that infinite possibilities are there. So theoretically, we can input our information, infinite information we can input at any quantum circuit. Theoretically, this is theory, only on theory based, on this logic. Yeah, this logic is true. We can input, but this logic is again limited by the hardware. Yeah, we can input if we are having an interface of hardware there. So the limit again here is for hardware. But yeah, theoretically, it is a so much a strong logic. We can have an infinite states to do calculations for the quantum. So yeah, I think the time is overcrossing the things. So we will the rest of the things we will discuss more tomorrow, because a lot of things, curtain raising programs has taken away from us. So we are missing that things. So I would like to end this session here. So and we'll like to join tomorrow at the 3 to 5 p.m. session for the rest of the things.
Yeah, sure, sir.
So
Thank you
hand
so
it over
much.
to the Nitya.
Yeah,
Yeah.
sir, Sushmita here. Thank you so much, sir, for your informative session for day one. We'll meet again by tomorrow at 3 p.m. Thank you, sir.
Okay, thanks.
Yeah, so dear faculty members, attendance link has been shared on a chat. It is just a reminder, kindly mark your attendance. As we informed in the starting, 60% of attendance is mandatory to get the certificate. And one more main important thing, we will be sharing the attendance link on chat, both Zoom, YouTube, and even it is updated in LMS. So attendance link will be shared at 4:30 and it will be active only till 5:30. So before 5:30, you have to mark your attendance. Okay. And this is the faculty development program. Only for the faculties we will issue the certificate. Yes, of course, students can join the session, but they will not get the certificate. Okay, this is the faculty development program. Only for the knowledge purpose, students can join. Okay, fine, we'll wind up for the day.
Hello. Yeah,
Yeah,
one
yes,
minute.
sir.
Yeah, Sushmita ma'am. Just now I have seen some questions from the for YouTube viewers. So for the 5 minutes, 2 minutes, I want to tackle that questions.
Sure,
Okay.
sir, you can.
Yeah. So there is a question from one student that have we physically quantum computer? Yes, we are developing the quantum computer. The Indian Institute of Science and developed the 6-qubit quantum computation. And from the IBM side, they are working from the long time. And now they have developed 1000 qubit hardware of the quantum computation. And the aim is here is to develop that things. The startup here in our India, that is a QPI. QPI is now aiming for the 25 qubit quantum computation. And when we will talk about more about this overall development when we will talk about this hardware session, I think on the day 3rd or day 4th. Right. There is one more question. May I know the difference between the quantum computation and the optical computer? Yes, the in more detail, I will also talk about this question. Okay, so no worry about that question. We will have the we will I will also include more about this difference between the optical and computer on the day 3rd when we are dealing with the hardware side. Okay, so for as of now, I can tell you about that because we are lacking with the time. So that yeah, optical computers we are dealing with the name decided we are dealing with the optics, right? So that what we have to do, we have to make a superposition states. So that's why I was saying that we are in the developing stage. So there are a lot of R&D are going on that how we can make it 0 and 1, by what hardware we can make it. So it may depends on you. You can also contribute. So you can also have the thoughts. There's some of the sensing things we can sense a 0, we can sense 1, or you can sense a mix of 0, 10% or 90% possibilities, 80%, 20% possibilities. So if we can sense these parameters, so that means in the optical, we have this way to sense these parameters 0 and 1, right? So yeah, Sushmita, we can wind up the session.
Yeah, sure, sir. Thank you so much.
Yeah. Okay.
Yeah, thank you all. Thank you for joining. We'll meet again by tomorrow at 3 p.m. Thank you, everyone.